Okay guys, so here is part 3 of the day 6 notes. We are once again solving exponential equations. Okay, so here we have Newton's law of cooling. So we will have to use this formula for this problem, and you will have to use this formula for your homework assignments. So where it has for your homework assignments the Newton's law of cooling, make sure you're using this formula. So you might want to box it, star it, highlight it so you remember that, okay? So it says you are driving on a hot day when your car overheats and stops running. It overheats at 280 degrees Fahrenheit and can be driven again at 230 degrees Fahrenheit. If R equals 0.0048 and it is 80 degrees outside, how long in minutes do you have until you wait until you can continue driving again? Now we do need to talk about what each of these variables represent. So T naught, this is what we call the initial temp or initial temperature, okay? When you have T sub R, that's what we call the room temperature or room temp. Okay. R is once again going to be your rate as a decimal. This is going to be the rate of cooling. I think we should know what T represents. That represents time. And then once again, we have that plus TR. Once again, that is just your room temperature. Okay. And when it says room, that means like either your inside temperature or the outside temperature there. Okay. So that's what they mean by room temperature, is the inside. Like if you were in a room, what is the temperature? Or if you were outside, what's the temperature outside? Okay. Okay, so now we need to make sure we plug in these numbers. Oh, and if you don't know what this T is, that's basically your final temp. Okay. There we go. Okay, so basically what temperature you want something to be at. Okay, now we need to plug in some numbers because we know we'll have to do that. Okay, first it says your car, it overheats at 280 degrees, okay? So basically your car is at 280 degrees. So that is going to be our initial temperature. That's the initial temperature of the car. Now we want to drive it once the car is at 230. So that is what our final temp, that's what we want it to be. So I'm going to put 230 here, okay? Now if R equals, now they have actually already put your rate as a decimal, so you really don't have to change it. So that's the nice part, they were doing that. And it's 80 degrees Fahrenheit. So that 80 is going to be your room temperature because that's your outside temperature. So where we see T sub R, we're going to have minus 80, and then we have E, right? So we have our rate, so we'll have negative 0.0048, okay? And then once again, our plus T sub R, that was 80. Now we are figuring how long do you have until, or have to wait until you can continue driving. So that means since we're trying to find time, we're trying to solve for T here, okay? So we are going to use the methods that you have learned to basically just solve an exponential equation. Now I do see E. That means when we solve, we will have to use the natural log on both sides. Now in order to do that, I do need to isolate my base, okay? So just like we did in that past problem, and I think actually was the very past, we need to isolate the base. In this case, it's going to be that e to the negative 0.0048t, okay? Okay, the first thing is I do notice that 280 minus 80, I can actually combine those as in the parentheses. So rewriting this out, 230 equals 200 e, and then our rate, which I'm not going to say again, there we go, then plus 80. Okay, now multi-step equation, trying to get that base all isolated. I subtract 80 first. Okay, so once I do that, I should get 150. Now I'm going to go ahead and divide both sides by 200. I'm going to go ahead and just make this into a decimal because it's fine to get decimals here. Yeah, so I got 0.75. It'll just be easier when we have to plug all these things into our calculator. Okay, so now to get rid of that e, remember I have to do the inverse. And the inverse of e is natural log. So I'm going to take the natural log on both sides. So when we have the inverse properties, remember they cancel out. So the natural log and e cancel out. So now I have natural log of 0.75 equals negative 0.0048t. And we're trying to get t all by itself, so I'm going to divide both sides by that decimal. And don't forget the negative there. Okay, now we're just going to plug this into our calculator. So I do natural log of 0.75. And then divided by this value of negative 0.0048. There we go. I get about 59.93. I would say because we're talking about minutes, let's just go ahead and round up to the nearest minute, which in this case is going to be 60, right? Okay. So basically it's going to take you about 60 minutes to let it cool to the correct temperature, or to the temperature that you need, which is 230. Okay. Okay, make sure if you have any questions, you contact me, and make sure you work on the homework assignment. I'll see you guys later.